Hey everyone, this is your review lesson on multiplying and dividing fractions. Unlike adding and subtracting fractions, which require common denominators, or least common multiples, multiplying and dividing fractions do not, and here's why. When you add or subtract a fraction, you are either putting two parts together or taking one from another. And that's really important to conceptually understand. And here's why again. Let's say you're being asked to add 3/4 and 2/3. Lots of people will automatically then say the answer is 5/7 because, well, it makes sense. 3 plus 2 is 5 and 4 plus 3 is 7. But if you put the shaded parts and both of these fraction bars together, you can see that you're not going to have 5/7 of a fraction. The numbers would match, but like from here to here, but the quantity would not. And that's a big difference. Here's why. 2/3 and 3/4, what you have to do then is to convert them into numbers that are proportional. 2/3 is the same amount as 8/12. And 3/4 is the same amount as 9/12. There are multiple ways in which you can figure that out. You can cross multiply and divide, like 2/3 blank over 12. 2 times 12 is 24. 24 divided by 3 equals 8. Or you can say, what times 3 gives me 12, which is 4, and then do the same thing to that numerator, and then you would get 8. So after you've done that, you can see that 8/12 plus 9/12 turns into the improper fraction of 17/12. You don't add those denominators because you just converted them into numbers that you can use. This simplifies into the mixed number of 1 and 5/12. To subtract, you would follow the exact same procedure up until you get to this point, where then you would subtract the second numerator from the first. 9 minus 8 is 1, and you're done. Multiplying and dividing fractions means something completely different. So what does multiplying fractions actually mean? Multiplying fractions shows how much space two fractions share. And look at this next example. 3/4 times 2/3 equals 6/12. Here's why. I created a grid using the least common multiple of 4 and 3. Or you can just multiply them together and figure it out. 4 by 3 gives me a 12 space grid, which is 4 by 3. My 3/4 is represented by the red shading I did. And the 2/3 is represented by the blue. The amount where the colors overlap is the shared area. There are 6 rectangles out of a possible 12, which proves my answer. Here's another example. 8/9 times 1/2 equals 8/18. Again, I could have made that grid and make it work. Dividing fractions shows how much one fraction fits inside another. 2/3 divided by 1/4 is asking you how many times does 1/4 fit inside 2/3. Okay? So if we do that, 2/3 divided by 1/4, it equals 8/3. Now what I'm showing you here is the computation way, which is to find the reciprocal of the second fraction, multiply and simplify. So 2 times 4 is 8, 3 times 1 is 3, that's 8/3, that simplifies to 2 and 2/3. But what does that actually mean? Well, here you go. Why? If I do this, and here I'm using fraction tiles, I could have also used a number line. I made 2 equivalent fraction tiles. Here's my 2/3, here's my 1/4. How many times does this purple shaded area here fit inside this shaded area here? Here's 1, here's my second. This is where this whole number comes from. And this little space in between here, there are two small parts. That becomes the numerator, and then my denominator is how many of the little ones fit inside here. Here's another example. Try 3/5 divided by 1/2. Here I'm showing this on a number line. In this instance, I've made my number line, and I'm marking where 3/5 is located, which is there, and then I marked where 1/2 goes. Well, how many does this arc fit inside the top one? I can easily get 1 with this little bit of space left over. That's 1 space over the denominator of 5. Now, this isn't shown on this illustration, but if I had drawn my number line using graph paper, which I'm going to show in a few minutes, you'll see this more easily. It just depends on what type of model you're using. Here are some practice questions. I want you to show visually 2/3 times 1/5 equals 2/15, and 2/3 divided by 1/5 equals 3 1/3. I've given you the answer. Your job is to prove it. So pause this video, do it, then hit play and check your answer. Okay, 2/3 times 1/5. Okay, 2 times 1 is 2, 3 times 5 is 15, no problem. My directions are create a grid using the denominators. Here it will be 3 by 5. That's my grid here. Shade 2/3 of this grid. If you didn't know that 2/3 of 15 was 10, you multiply the fraction by how big the grid is. 2 times 15, and remember you can make a whole number a fraction by just adding 1 as a denominator. 2 times 15 is 30, 3 times 1 is 3, 30 over 3 simplifies to 10. I chose yellow to color it. Here are my 10 squares that I've colored. Repeat my same process for 1/5. This simplifies eventually to 3. I then drew that here. This area where it's shaded and shared, that's my answer. That's where this 2 came from, and my denominator is how big the grid actually is. Okay, now here's my number line. What I'm doing here is I find the LCM of both denominators, which is 15. Graph paper makes this so much easier. I drew a line 15 squares long. I then marked where 2/3 goes. That's the 10th space. I repeated my process for 1/5. Then I'm counting how many of these arcs that I've colored in pink fit inside this much larger arc or line marked by yellow. Here's 1, 2, 3. I've got 3. That's my whole number. This little space here is my 1, and my denominator of 3 came from how many spaces are in these arcs. See, 1, 2, and that would be 3 here. And then I can check it by multiplying by the reciprocal of 1/5, which is 5 over 1. 2 times 5 is 10. 3 times 1 is 3. 10/3 simplifies to 3 1/3. Watch this video as many times as you need to, and I hope that this clears up any confusions. Ask me questions in class. Thanks.